Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this equation. So our equation here is 2 to the power of 3x minus 1 equals 3 to the power of x minus 2. And our goal here is to find the value of x. Well, what we're going to do first is we're going to take the log subscript 2 of 2 to the power of 3x minus 1. And we're doing this because remember, the log is the inverse of an exponent. So when we're taking the log with subscript 2 of 2 to the power of 3x minus 1, we're essentially canceling out our base here because these two cancel out. The log is the inverse. So if these two cancel out, then all we're left with is 3x minus 1. And we've just simplified our equation by a lot. However, what we do to one side of the equation, we have to do to the other side. Meaning, we're going to have to take the log with subscript 2 of 3 to the power of x minus 2 as well. All right, so now what we're going to do this is we're going to use an important property of logarithms, and that is the power property. And that states that if we have a power here, we could go ahead and move this in front of the logarithm. So this would be x minus 2 times log subscript 2 of 3. And I'm going to put parentheses over here. So this is an important property of logarithms, and this still equals 3x minus 1. So now what we're going to do is we're going to distribute our log with subscript 2 of 3 to this x minus 2. So this is 3x minus 1 equals, well, x times log subscript 2 of 3 is simply x log subscript 2 of 3 minus 2 times log 2 3 is simply this. All right, so now as you can see, we have our equation here. And now what we're going to do is we want to get all the x's, all the terms with x on one side. So what I'm going to do is I'm going to add 1 on both sides to get rid of 1 on this side. And then I'm going to subtract x log on both sides so that this can be on this side and all the terms with x can be on the same side. All right, so this gets us to 3x minus x log equals negative 2 log plus 1. All right, so now what we're going to do is we're going to factor out x over here. We're going to factor out x from this expression. So if we factor out x, well, 3x divided by x is simply 3 minus x log divided by x is simply just log subscript 2 of 3 and this equals, well, I could just say 1 minus 2 of log subscript 2 of 3. All right, so now let's bring this over here. So now what we're going to do is we're going to divide by 3 minus log subscript 2 of 3 so we can isolate x. So if we divide by this on both sides, If we divide by this on both sides, we get that x here equals 1 minus 2 log 3 over 3 minus log subscript 2, 3. And this is our exact answer to this logarithm. However, people usually want a roundabout. They want a not exact answer, but an answer close to it. And this is x is approximately equal to, well, for this, we want to use a calculator because we can't get the exact answer just on paper. We need to use a calculator. So if I use my calculator here, I get negative 2.946. And this is my approximated answer. So this is how you solve this exponential equation. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n is equal to 2016. Now, by knowing this, we could actually decipher a couple things. Because this is positive, 2016 is positive, we know that m has to be greater than n. Because if m was negative, then this would actually be negative. And if n was greater than m, this would actually be negative 2016. So by knowing this, we could just say that m is equal to n plus k. K being a constant. So now if I subtract k on both sides, I get m minus k is equal to n. So now I'm actually going to replace m with, I'm going to replace m with n plus k. So now we have 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now this can also be written as 2 to the power of n times 2 to the power of k minus 2 to the power of n is equal to 2016. And now if I factored out 2 to the power of n from this, I would get 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. So now 2016, well, this is actually equal to 32 times 63. So now we have 2 to the power of n times 2 to the power of k minus 1 is equal to 32 times 63. And now 2 to the power of n, this is actually going to be an even number because 2 to the power of anything is going to be even. And 2 to the power of n minus 2 to the power of k minus 1, well, that's going to be odd. Now 32, well, that's an even number, so I'm going to write e for even, and 63 is odd. So meaning we could just say that 2 to the power of n is equal to 32, and 2 to the power of k minus 1 is equal to 63. So if 2 to the power of n is equal to 32, then n is equal to 5, because 2 to the power of 5 is equal to 32. And we have 2 to the power of k minus 1 equals 63. If we add 1 on both sides, we get 2 to the power of k is equal to 64. Meaning k is equal to 6. So now if n is 5 and k is 6, well, we could simply plug these into this. M is equal to n plus k, and n plus k is 5 plus 6, which is 11. So m equal to 11. So now these three are our values.